We've been lied to about what intelligence looks like. For the last few years, we've lived in a state of collective awe, watching chatbots write poetry, pass the bar exam, and code entire websites in seconds. We called it a godlike intelligence. But here is the uncomfortable truth. Every mainstream, you have used the ones currently dominating the headlines, utterly fails a specific, simple reasoning test that a 10-year-old could solve. Ask a top-tier LLM a question involving 3 people moving items between rooms in a house. Then ask where a specific item is after 5 movements. The AI will confidently, eloquently, and completely hallucinate the answer. It is an embarrassment that the industry has tried to hide behind the wow factor of creative writing. But while the giants were busy polishing their prose, a new kind of AI has been quietly emerging in the shadows of research labs. It doesn't just mimic, it thinks. It doesn't just predict, it reasons. And it is currently outperforming not only its predecessors but, in many cases, the very humans who built it. We are witnessing a paradigm shift that turns everything we thought we knew about artificial intelligence on its head. To understand where we are going, we have to admit where we are. We are currently living in the era of the Stochastic Parrot. Large language models, LLMs, are, at their core, incredibly sophisticated autocomplete engines. They excel at prediction, but they lack a fundamental grasp of understanding. When you prompt a model, it isn't thinking about your problem. It is calculating the mathematical probability of the next word based on a trillion-parameter map of human language. Think of it like a student who has perfectly memorized every page of a medical textbook but doesn't actually know how the human body works. If you ask a question that appeared in the book, the student answers flawlessly. But if you present a brand new medical mystery that requires connecting disparate dots, the student collapses. This is the gap between surface intelligence and real problem solving. We have been mistaking fluency for brilliance, and the illusion is finally starting to crack. The failure isn't a lack of data. It's a structural flaw. To illustrate this, let's look at state tracking. Imagine a story. John puts a red ball in a blue box. Sarah moves the box to the kitchen. John takes the ball out and puts it in his pocket. Sarah takes the blue box to the attic. If you ask a standard AI, "Where's the ball?" it often gets lost. Why? Because it struggles to track the state of objects over time. The technical culprit is something called static positional encoding. In traditional LLMs, the model sees a sequence of words, but it doesn't have a dynamic mental map of how variables change. It's like trying to watch a movie through a series of disconnected Polaroid photos. It sees the now, but it loses the why and the how of the sequence. As the complexity of a logic chain increases, the model's blindness grows exponentially. It can tell you what a red ball is, but it can't keep track of its journey through a shifting environment. Enter the Large Reasoning Model, LRM. If the AI we know today is a reflex system answering instantly, and without thought, the LRM is a deliberative system. This is the difference between a grandmaster playing bullet chess, relying on pure instinct, and the same grandmaster playing a 3-hour tournament match, calculating 20 moves ahead. LRMs are designed to deliberately slow down. Instead of generating the first word that comes to mind, these models use additional computation during the inference phase, the moment between you hitting enter and the model replying. They use this time to explore different logical paths, check their own work, and discard dead ends. This is the shift from AI as a search engine for words to AI as a logical engine for thoughts. So, what does this thinking actually look like under the hood? It's called chain-of-thought caught reasoning. In new models like OpenAI's O1 or Google's advanced reasoning prototypes, the AI generates a long internal monologue that the user often doesn't even see. It lays out a hypothesis, tests it against the rules of the prompt, catches its own errors, and pivots. It uses internal voting, where multiple branches of thought are generated simultaneously, and the model selects the most logically sound path. This isn't theoretical. Open source research from China and internal projects at the world's biggest tech hubs are already delivering elite-level results in mathematics, physics, and complex coding areas where traditional LLMs historically face-plant. They aren't just getting smarter. They are becoming careful. A major breakthrough in this evolution comes from MIT, with a concept called path attention. In a standard AI, every word in a sentence is weighted against every other word in a somewhat static, distance-based way. but path attention changes the game. It treats the relationship between concepts as a dynamic path through a landscape of meaning. The metaphor shifts from reading a map to walking the terrain. Instead of just seeing that two words are near each other, the AI understands the causal journey between them. Context becomes something that is lived and experienced by the model as it processes the logic, rather than just a fixed coordinate in a database. This allows the AI to follow evolving variables with a level of precision that was previously thought impossible for neural networks. However, this newfound brainpower isn't free. There is a brutal economic reality behind reasoning models. They are incredibly expensive. Traditional LLMs are fast and cheap because they take a straight line from input to output. Reasoning models take a zigzagging, self-correcting route that consumes massive amounts of electricity and compute time. Some complex reasoning tasks can cost hundreds of dollars in inference tokens just to reach a single conclusion. But the market is signaling that for high-stakes decisions like legal strategy, drug discovery, or engineering, the cost is secondary to accuracy. We are seeing a bifurcated market: cheap AI for writing emails, and expensive AI for solving the world's hardest problems. Yet, just as the first computers cost millions and eventually fit in our pockets, we are already seeing rapid cost compression and open-source alternatives that aim to democratize this slow thinking. But let's pause the hype for a moment. Despite these leaps, the reality check is sobering. On true reasoning benchmarks, tests designed to measure novel problem-solving that is in the training data, even the best models still struggle. We are far from artificial general intelligence, AGI. Speed is a major bottleneck. Nobody wants to wait 3 minutes for a chatbot to tell them a joke. This is forcing a total redesign of how we interact with AI products. Furthermore, industry leaders are starting to admit that scaling, simply adding more data and more chips, is hitting diminishing returns. The brute force era of AI development is stalling, and we are realizing that making a model bigger doesn't necessarily make it wiser. The future isn't just in bigger neural networks. It's in the hybrid. Researchers are now looking at merging neural intuition, the LLM's ability to predict and create, with symbolic logic, the rigid, rule-based math that runs traditional software. This neuro-symbolic approach aims to create a system that has the creativity of a poet and the discipline of a mathematician. There are even experimental forays into quantum classical systems, where quantum processors handle the massive probability trees of reasoning while classical silicon manages the output. These experiments suggest that real cognition, the kind that rivals the human mind, might require architecture that moves beyond simple statistics and into the realm of structured, multidisciplinary synthesis. While the software engineers get the glory, the hardware engineers are the ones making this possible. Behind every reasoning model is a new generation of hardware. We are moving away from general-purpose GPUs and towards specialized inference engines and energy-efficient servers designed specifically to handle the thinking phase of AI. The race for next-gen chips like NVIDIA as Blackwell or Google's latest TPUs isn't just about speed anymore. It's about sustainability and scale. To make reasoning models viable for the masses, we need chips that can perform quadrillions of calculations per second without melting the power grid. The hardware undercurrent is the silent engine driving the transition from chatty AI to thinking AI. We are at the threshold of a profound philosophical shift. We are moving from AI that predicts language to AI that models the world. This is the difference between a parrot mimicking the sound of fire and a person understanding that fire is hot, dangerous, and transformative. When AI begins to model concepts and logic rather than just word frequencies, intelligence itself is redefined. We are moving away from surface fluency, the ability to sound smart, and toward internal structure, the ability to be smart. This shift will fundamentally change our relationship with technology. We will stop asking AI to write this for me and start asking it to think through this with me. In the end, it's important to remember that these new reasoning models aren't here to replace the AI we've grown used to. They are here to complement it. We are entering an era of dual-core intelligence. The fast models, LLMs, will handle our everyday tasks, summarizing meetings, drafting emails, and providing quick information. The slow models, LRMs, will handle the impossible, solving climate change puzzles, identifying market collapses before they happen, and pushing the boundaries of science. The real transformation isn't a competition between human and machine or model and model. It is the opening of a new frontier of problems that were previously beyond our reach, now suddenly sitting within the grasp of our tools. From this journey into the heart of AI reasoning, we can draw a powerful lesson for our own lives. Speed is not the same as intelligence. In a world that demands instant reactions, the most successful systems, biological or artificial, are those that know when to slow down, deliberate, and check their own biases. Practice System 2 thinking. When faced with a complex problem, don't go with your first predictive gut reaction. Force yourself to write out a chain of thought on paper. Verify, don't just trust. Just as we now know LLMs can hallucinate logic, remember that your own internal autocomplete can do the same. Always look for the underlying state of the variables in your life. Embrace the hybrid. Use tools for what they are good at. Use AI for brainstorming, fluency, but use your own critical reasoning, state tracking, to finalize the plan. I wish you all great health and the wisdom to see through the illusions of the digital age. If you found this deep dive into the future of intelligence valuable, please subscribe to the channel, hit the notification bell, and join our community of forward thinkers. Together, we'll stay ahead of the curve. Until next time,